All right, lesson 4. So an annuity is a different type of investment. It's a sequence of equal payments. That's a key word here, equal. Made at equal periods of time. All right. So in an annuity, instead of putting money into a bank account one time only, you put money into your account on a regular basis, like every week, day, month, whatever. But an annuity requires you put the same amount in every time. They are compounded, but we use a separate formula for them. I'm going to show it to you. You don't have to write this down, but I just want you to see it's kind of nasty. There it is. Now you can see some of the similar basis. Right here is the future value formula we were doing, but it gets way more complicated, as you can tell. So we're not going to worry about that because we have this lovely calculator that can do a lot of magic for us. All right. So it says you deposit $200 every month. Okay. So remember in previous lessons we talked about not using the payment? Well, here we are going to do a payment. So $200 per month. Earning 6% interest. That's easy. That's right there. Now, present value, we have no money in it yet. We're starting it. Okay. Future value is what we're going to solve for. Okay. Now, it says 10 years. Now, the key here is every month. That's where we're putting it in. So we're doing it monthly. So that's the compounding period. So we're going to put in 12 here. The calculator will automatically change that to 12. All right. And then this N is going to be like we've done before, the compounding periods times the number of years. So 12 for 1 year, 24, all the way up to 120. Almost at 240. All right. So what we're going to do now is get our calculator, and we are going to put this information in. So we're going to go up here to N and put 120. Get this a little bit higher. 120. Come down here to interest, and we said 6%. Present value is 0 because we're starting the account. Payment is 200 monthly. The future value we don't know, but we leave it there because if we clear that out, it won't function. And then we're going to say 12. And again, as soon as we hit enter, boom, see why it changes. We go up here to future value, and we're going to hit alpha solve. And there is our money right there. So 32,700 and whoopsie, this is a bad 7. $75.87. Now, how much money have you put in yourself? Your total contributions is your payment times the number of months times the compounding period times the number of years. So 200 times 12 times 10. So that's $24,000. So you put in $24,000. How much interest did you earn? Well, for that, you're going to take the 32,775.87 minus the 24,000. And that is all gravy. How much you earned? 8,775.87 cents. So that's how much you made off of that investment. So you put in 24,000 and you made about almost $9,000 in profit. So what's the difference between an annuity problem and a compound problem? Using the compound formula, when you're depositing the money into taking money out of an account one time only. For these type of problems, you'll be using PV and FE, but not payment. Payment 0. For the annuity, we're putting money in monthly. Okay. If a problem is an annuity, then the number of compounding periods will be determined by the time intervals you're depositing the money. So that's why before when I said if we're putting it in monthly, that is the compounding period. All right, example 2. What type of problem is this? Compound or annuity, and why? The lady put $1,673 into her savings every 6 months for 2 years at 3% compounded semi-annually. How much will she have? All right. So the fact that she's putting an amount of money in at a regular time frame for a certain period of time tells you this is an annuity. Okay? So we have our N, we have our I, we have our PV, we have our payment, and we have our future value, and we have PY, CY, which will be the same thing. Okay? So interest, 3%. Present value, 0. The payment we're putting in is $1,673. Future value, we don't know. PY and CY, okay, those are going to be the same thing. We're doing it every 6 months. That's twice a year, okay, for 2 years. So that gives us number up here, 2 times 2. So get our calculator out. We come up here. N is 2 times 2, which is 4. The interest rate is 3%. Present value stays 0. Payment, she's putting in $1,673. Future value will calculate, and this is 2. Again, it automatically changes. We go up to future value, alpha, solve. So she has in the account $6,844.08. Number 3, what type of problem is this? The man put $1,673 into his savings account for 2 years compounded semi-annually at 3%. He put it in one time, and then it's going to be compounded semi-annually. So this is compound interest. All right? So this is going to be almost exactly the same, except the $1,673, that is going to go into PV, not PMT, payment. Okay? Otherwise, the numbers are going to be exactly the same. So we're going to come up here. We're going to leave the 4 and the 3 and change this present value to $1,673 and change this payment to 0. And then go to future value and hit alpha solve. So what does she have here? This man has here, he only has 1775.66. Now you might think, well, that's a ripoff, but remember, he only put in a one-time investment. Okay? She put in this every 6 months. Okay? So this is not all profit. All right, example 4. How long will it take to become a millionaire, all right, if you invest $100 a week into an account earning 9.3% interest? Okay, so we're trying to calculate this. How long? Okay, now my interest is 9.3. My present value is 0. My payment is $100. Okay, and we want $1 million future value. So 1 with 6 zeros. And we're doing it weekly. Okay, now remember, the solve is tricky because this is really 52 times a number, okay? So the answer we get there is not going to be the actual answer. We need to divide by the 52, all right? So here we go. Last one. So we don't know the number of years or number of periods. We're going to put in 9.3. Present value of 0. Payment is going to be $100. Future value is 1 million. 1, 2, 3, 4, 5, 6. And we're going to change this to 52. Now we're going to go up here to N and hit alpha solve. Oh, we got the error again, right? So whenever we have this error, we got to remember to change this to negative 100. It's the few times when you have to do the trick. Okay, so whoops, that was my bad. Forgot to move it. Negative 100. Go up here, hit alpha solve. Okay, so there's our answer, 1644 point, let's say, just say 42. So 1644 point, I'll just put the whole thing, 415776. Now what we need to do is do that number, 1644.415776, dividing by 52, and we get about 31.6 years. And the reason we had to divide by 52 is because this number is the product of two numbers. So 1644 is actual n, but since we're trying to find the number of years, we need to divide by 52. And that is it.